How is it helpful to know that the human brain is a dissipative structure? Knowing that the brain is a dissipative structure is useful, since it allows us to apply to the brain certain facts known to be true of all dissipative systems. First, we know that dissipative structures must constantly dissipate entropy. For order to develop within the system, entropy must be externalized so that the net entropy of the system and its environment will increase, thus satisfying the second law of thermodynamics, and so that the entropy does not increase within the system itself, thereby killing it by causing it to run down, wear out, or approach equilibrium. We also know that the only way entropy can be dissipated is for the system to have a constant input of energy and new materials. An example is the whirlpool effect in flowing water. This must dissipate entropy, which it does by the centripetal force of the whirling vortex, but to do this, to maintain its existence, it must have a continuing flow of water into the vortex. If the influx of energy were to stop, that is, if the vortex were to suddenly be placed in a motionless body of water, the vortex itself would cease to exist. Well, that's just great, but how in the world does this tie in with the brain? What this means for the brain is that the only way it can maintain itself is by receiving a constant input of energy and new materials, and scientists have repeatedly found this to be true. Children who are placed in environments lacking in appropriate mental and visual stimuli do not develop so fast or well as the babies who are brought up in nurturing environments filled with visual and auditory enrichment. Similarly, rats placed in enriched or impoverished environments display enormous differences in brain weight and size and in the innate complexity of the brain structure, while rats placed in a non-enriched environment showed an almost immediate decrease in brain size and complexity. Another thing we know about dissipative structures is that, as open systems in far from equilibrium environments, they receive unpredictable and widely varying kinds of energy input. High energy influxes set up fluctuations in the system. Within certain limits, the structure can absorb or damp these fluctuations, but if the jolts and jars become too violent, the structure may be broken out of shape and escape into a higher form of order. In the case of the brain, this escape into a higher order is experienced as having a new idea. This is what we refer to as the eureka, even that moment where you think, aha! It is that light bulb going on over your head, that special movement or leap into a higher level of connectedness and complexity is what we mean when we talk about learning. Okay, so this stimulation of the brain, this input into the dissipative structure, that's what makes it brain enhancement. Relating this to the brain as a dissipative structure, we can say that the brain is able to accept certain amounts of energy input, such as ideas or events, and assimilate them without any serious challenge to the internal organization of the brain. Yes, we say in response to certain ideas or stimuli, this all makes sense to me now. However, at a certain level of intensity, the external events or stimuli become too intense, the brain's fluctuations become too great to be damped, and the brain will escape from its old pattern into a new organization of higher order and coherence. First, things no longer make sense, and then, with a shock of recognition, they make a new type of sense. Artistic creativity plays a large part in the brain's ability to increase its functions. Brain enhancement processes that relate to artistic creativity. The idea of brain enhancement and the process of brain enhancement as it relates to artistic creativity, a characteristic of dissipative structures that is particularly important in or understanding of the brain stimulation, is that, in order for transformation or creation to take place, there must be either a lot of instability and fluctuation within the system, so that even a small stimulus can bring about dissolution and reorganization, or, on the other hand, if the structure is stable, there must be some extraordinary influx of energy into the system, something powerful enough to destabilize a structure that is strong enough to resist most fluctuations. Okay, so how does this knowledge apply to the brain's ability to adapt and evolve, but most especially its ability to create? In the first case, we can see that the greater the instability of the system, the greater the number of interactions among its various parts, the greater its susceptibility to fluctuations and disorder, and the greater its potential for evolution, transformation, diversification, evolution, and, in the case of the brain, wisdom. Thus, the theory of dissipative structures supports the long-standing assumption that artists, creative thinkers, and others who are constantly seeking to open themselves to new ideas are on the whole more mentally fluid, more susceptible to turmoil, chaos and disorder in the brain. Lest this sound forbidding, remember that on the opposite side of the artistic coin, so to speak, creative thinkers also most likely have a richer and denser neural network, with greater numbers of interconnections between their neurons. As a result, also have a greater number of potential mental states, that is, a wider range of ideas, feelings, sensations and intuitions. And of course it is out of chaos, turmoil and disorder that higher levels of order and wisdom emerge. Thus, if the creative thinkers have less mental stability than some people, they also experience higher levels of mental connectedness, complexity and evolution. If that's the case, then what does this theory imply for people who are less creative and might resist innovation and change? On the other hand, we can also surmise that people who are set in their ways, who resist any new idea, who hate to try any new experience, who refer every idea or experience their past, attempting to fit it into the structure of their brain without causing fluctuations or perturbations. Moreover, who are always sure they are right and never experience self-doubt, these people, whatever their feelings of self-satisfaction, are trying to eliminate the influx of new energy and matter into their brains. Since, as we know, open systems cannot exist without a constant flow through of new energy, what these people are essentially trying to do is turn their brains into closed systems. What implications could these efforts to turn the brain into a closed system have? The idea of a closed brain is much like the idea of a steam engine, or a cup of coffee that has gone cold, even a stone. Certainly, these closed systems are not threatened by chaos or disorder, but after all, who wants to have a near-equilibrium brain? Although this sort of brain, like a rock, would never be destabilized, it would also never have a new idea or feeling, either. It would lack so much of what makes the human brain special, unique and creative. In any case, physiologically, brains such as these would in all likelihood, have far fewer neural connections and much less developed cortical layers than would the brains of people who remain open to and welcoming of stimulation and the natural energy of ideas. Developing strategies in brain enhancement is a growing demand we all can benefit from in our lives.